Good morning, everybody.
Good morning.
Good morning, teacher.
So yesterday we were working with the undetermined coefficients method, and I just would like to highlight that the undetermined coefficient method. Let me write it here. This method, we will use this method in order to find a particular solution. That means it's not the full solution. In the next lecture, we will work on how to find a full solution for this kind of ODEs. So I just want to highlight that fact. We are just finding one particular solution. And as you can remember, what is the method? Well, if it can be called a method, you just guess the solution from the observation of or the analysis of the forcing function, the right side of the equation, you guess the solution. So yesterday we saw that if we have an exponential on the right side, our guess has to be an exponential for the solution, for that particular solution. And if the right side or the forcing function is a sine function or a cosine function or a sum of sine and cosine functions, then your best guess is a sum or addition of sine and cosine functions with undetermined coefficients. And that's where the name for this method comes from. So let's work with a third example. In this time, the forcing function is a polynomial. In this case, we can see it's a third order polynomial. So our guess for the particular solution will have the form of a polynomial. Why? Because you know that in this equation, we're saying that whatever y of t is, that's the solution, you have to take the first derivative of that y, take the second derivative of that y, multiply 4 times the first derivative and subtract it from the second derivative, and to that result you have to subtract 12 times your y function. So in order for all of this addition to give us a third order polynomial, you need to have somehow a t cube or a t, or maybe it's t squared, why not, on the left side. That's why we can make our guess as a polynomial with undetermined coefficients. So I need a t cube with my undetermined coefficient, my t squared, my t, and an independent coefficient, of course.
Teacher, could you repeat, please, why is it that you're choosing t cubed, t squared, and t?
Yes, of course. Remember, in this equation, what you are saying is, if you propose that your solution will be y, that solution should make this equation true. And what does that exactly mean? Well, you take your y and multiply it by 12. You take your y and take the first derivative and the second derivative. And then you do this operation, this addition. To the second derivative, you have to subtract 4 times the first derivative. You have to subtract 12 times y. And that should give you something like this. And what do you need to have on the left side in order to have some term like this? I can imagine something like 6t cubed minus 4 times cubed. That will give me 2 times cubed. So on the left side, I need some terms with t to the 3. And you need something like this, and you need something like this. So on the left side, you need some terms with t to the cube, with t, and with an independent coefficient. And maybe you need some terms with t squared. So our guess is a third order polynomial. That's the reason. Is that clear?
Yes, teacher. Thank you.
Okay, so you just can propose having something like e to the 3 times t on the left side, because you don't have any exponential on the right side. You cannot propose something having cosine of 3t or something like that, because on the right side, you don't have any cosine function, right? So whenever you see a polynomial on the forcing function, you propose a particular solution, and this is, let me write sub p, just to check, just to remark that this is just one solution. This is not the full solution for this ODE. Okay, so this is our guess as a particular solution. So this particular solution should make this equation true. In order to prove that, we need to take the first derivative and multiply it by 4. So the first derivative is equal to, well, this is really simple this time. And the second derivative will be this one. So we multiply these derivatives by the corresponding factors in the equation, and let's do the subtraction. So we have that replacing these values on the equation will give us this expression, minus 4 times y prime and minus 12 times y. 12 times time. And this has to be equal to the forcing function. And the forcing function is 2t cubed minus 2. Minus t plus 3. So we have replaced our y function and its derivative on the ODE. And from here, we're going to be able to find the values for our undetermined coefficients. And we have 4 undetermined coefficients, so we're going to need 4 equations. And how do we get those 4 equations? We just compare the coefficients on the right side with the coefficients on the left side. They have to be equal. So the coefficient of t cubed has to be equal to 2. The coefficient for t squared will have to be 0. The coefficient for t will be -1, and the independent coefficient has to be equal to 3. So just let's find the common terms and let's factorize them. So we have all of the terms with t cubed. Let me do this. So here is a term with t cubed, and I think it's the only one. So we have -12a cubed. Now the terms with t squared is 1. Here's another 1, and that's all. So we have plus -12a minus 12b times t squared, and then the terms with t. We have 6at negative abt. Oh, here's another one. So we have 6a minus 8 times b minus 12c times t. And finally, the independent coefficients. It is 2b minus 4 times c. Here is 1, here's our 1. Oh, and there's a third one. Told you. Okay, and that has to be equal to 2 times t cubed minus t plus 3. So this equation implies that -12a has to be equal to 2. That's our first equation. -12a minus 12b should be equal to 0 because there is no t squared on the right side. And 6a minus 8 times b minus 12c should be equal to -1. And finally, 2b minus 4 times c minus 12d has to be equal to 3. So this is our system of equation. We have 4 equations to determine the 4 unknowns. And from the first equation, we can get easily the value for our coefficient a. So a is equal to -1/6. And replacing that value over here, we have +12/6, which is equal to 2. So 2 minus 12b is equal to 0. And from here, we can see that 12b is equal to 2. So b is equal to 1/6. Now we can replace the value for a and b on the third equation. Let's do it over here. Now we have 6 times a, which is -1, minus a times b, which is 8/6, or simple 4/3, right? Minus 12c, and that should be equal to -1, and from here we can get, and this addition will give us 3 times 3 is equal to 9, plus 4 is equal to -13/3, and that will be added to -1. And that gives us -3 plus 3, 10/3. So C will be equal to -10/36. Is that correct?
Teacher, -1 minus 4/3 is -7/3.
-7/3. And where are you saying it? Over here?
The 13/3 is 7/3.
3 times 3. Oh, you're right. 3 plus 4 is equal to 7, right? Thank you. So we have a 7/3 over here. And then we have -3 plus 7, which is equal to 4/3. Is that correct? So we have -4/36, and that is equal to what?
1/9.
1/9, -1/9. That's our value for C. And finally, we need to replace the value for B, for C, and for D, right? Let me remark our solutions. This is A, this is B. Now this is C. And now the value for B is equal to 1/6. So we have 2 times 1/6, which is equal to 1/3, minus 4 times C, and C is a negative number. So we have, doing this, 4 times C. We have 4/9 minus 12 times D, and that should be equal to 3. And from here, we can find the value for D, and 1/3 plus 4/9, and 4/9 is just simple. No, it's not that simple. Okay. So 1/3 plus 4/9 will be equal to 9. So we have 3 plus 4 over here, minus 12D. And from here, we can see that -12D has
Teacher,
to be equal. Yep.
why this one is negative?
This one. The number 3.
No, the number one, this, oh, sorry,
Oh, okay.
this one. This one.
Yeah. This one, right?
Yeah.
I don't know. Isn't it?
I
-1.
think it is because we have -t.
from here.
Ah,
Here's the
okay, yeah.
coefficient. That's the coefficient for negative, for
Okay.
t.
Thank you, teacher.
Okay. So we have minus 7/9, and this will be equal to 20/9. Is that correct? And finally, we have a negative sign over here. This will be 20/12 times 9. And that's what? 20 divided by 9 times 2, 18 plus. Okay, and that's it's a negative. 20/108. That will be the result. Is that correct? Can we simplify
Yes.
this fraction? Can we divide
5/27.
Thank you. That's quite fast. Yeah, you're right. This factor of 4, and that's 27. That's right. So this is our coefficient D. Well, what we have done? Well, we just guessed that our solution for this equation was a polynomial, this kind of polynomial, a third order polynomial. We have a third order polynomial on the forcing function, so our guess will be a third order polynomial with undetermined coefficients. Then we found the first and second derivative, and we replace those expressions in our original equation. And from there, we establish a system of equations in order to find the values for our coefficient. I was looking at the system of equation, and here is our system of 4 equations on 4 unknowns, A, B, C, and D. And now we have find the values for those unknowns, which happen to be the coefficients for our guess. Now we can establish our particular solution, which is A times T cubed plus B times T squared plus C times T plus D. And now from the now determined equations, we can establish our solution. We say A times, and A is equal to -1/6 times T cubed plus B times T squared plus C times T plus D. And that's it. We're done.
Teacher,
Yeah.
I don't remember how did we know that it actually worked. I mean, like, we have the solution right now, but how are we sure that this satisfies like the initial like equaling? Because we know that this should be equal to 2t cubed minus t plus 3. So I don't remember how we were sure of that. I mean, because this looks quite different.
Okay. We make a guess. We just make a guess.
Yeah.
We're just guessing. This could be the solution.
Yes.
Now, how can you be sure that this is a solution? It's quite simple. whenever you have a solution for an equation, that solution must satisfy the equation. And we have done that. We have said, okay, let's find the first and second derivative and let's replace those values on our equation. If it is true that this is a solution, our guess has to satisfy the solution. And now, how do we know that it satisfies that equation? Well, if we are able to find the coefficients A, B, C, and D, then that's because this is a solution. Otherwise, we will not be able to find those values.
So if we were to put an incorrect guess, then once we try to solve the system of equations, it wouldn't be
Possible to solve it. It will not be possible to solve it.
Okay. Thanks.
Okay. So we are done. We have a particular solution for our ODE. Now from here, we now have found solutions for three kinds of forcing functions on the right side of the equation. Let's call that the basic functions. So we have three basic functions: the exponential function, the sine and cosine, or a combination of both of them, and the polynomial function. And these are the kinds of functions, of forcing functions, that with equations having those forcing functions are the candidates to use the undetermined coefficient methods in order to find a solution for them. So let's summarize that on a table, and let me copy a table for you. Okay, finally, here's the table. So in these tables, you can see the three basic kinds of functions that we can use undetermined coefficients on. So in fact, this is just one kind of function. A function, these two are just a special case for this case where A or B is equal to 0. So this is one kind of function, this is another one, and this is the third one. Three basic kinds of functions for the forcing function where we can use the undetermined coefficient method. And this is our guess for any one of them. As you can see, the guess for any of these three cases is just the same. A combination of sine and cosine with undetermined coefficients. And so we have the exponential, the sine and cosine, and the polynomial. And with the undetermined coefficient methods, these are the three kinds of basic functions that we can solve using the undetermined coefficients method. And of course, there can be a combination for the forcing function having an exponential and sine and cosine, or an exponential and a polynomial, or a sine and cosine and a polynomial, etc. So we can have some combinations. So let's work with those combinations in order to have more complex functions on the right side. But they will be just combinations of them. So just let's take a look at the details on how to work when we have combinations of these three basic functions on the right side, or the forcing function. Let me copy another example. So what if we have some forcing function like this one? Obviously, this is not just a polynomial, it is not just an exponential, but a product of an exponential and polynomial. In this case, this is a first order polynomial. So what is the guess solution? Well, first, let's think about the guess for the polynomial. So the guess for the t part will be a first order polynomial. So this is our guess. This will be our guess for the t part. And what is the guess for the exponential? It will be something like a coefficient. We have already used a and b, so let's call it c. And this will be our guess. So if we have a product of these two basic functions, we might think that the best guess we can do is a product of our guesses, right? So our guess for the product could be the product itself, right? Okay, the only problem with our guess is that we have three undetermined coefficients. And from this equation, if we replace this, we will get, eventually we will get only two equations. And we will have a problem because we cannot determine three unknowns from just two equations. We need three equations. So one better guess could be get as follows. What if we multiply this term by these two terms? We are left with something like e to the 4t times c times a times t plus b c e to the 4t. Or just let's multiply just the c. So we are left with okay. And what do you think about this?
The
This
constant could be absorbed.
The constant could be absorbed. Well, this constant is an unknown, and this constant is another unknown. So the product will be just an unknown. So we could call that simple A, and this unknown will be a new B. So our guess could be written like this one. Ta-da! So as you can see, as you forget about this whole process, A times T plus B is simply our guess for this polynomial. And e to the 4t is just the exponential without the coefficient, right? You can see it over here. It's just the exponential without the coefficient, and here is the polynomial. So we can generalize this result with saying that whenever you have a polynomial times an exponential, your guess will be the exponential without the coefficients times the polynomial. And that will hold true for every one of the basic functions times an exponential. You just write down the exponential and then you write down the guess for the basic function. So in this case, whenever you have a polynomial, you write down the polynomial times exponential. And if you have a sine, cosine, or an addition of both, you write down the solution for the sine or cosine times the exponential, and we are done. So whenever we have the product of an exponential with one of the other two basic functions, we now know what our guess will be. And it can be shown, of course, that this will be true, that this guess will be a solution for a case like this one. And let's do that. So we need to get the first and the second derivative. Of course, we need to do some operations. So in the case for the first derivative, we have to find the derivative of a product, of course. And what is the derivative of this expression? We can have the derivative for a to the 4t plus the derivative of at plus b, which is just 8 times the exponential. And that's the first derivative. And then we need to find the second derivative. And we need to find the derivative of this product, once again. So we have the first term and the second one, which will be 4 times a e to the 4t plus 8 times e to the 4t. So we have 5 over here. In fact, we can factor out the e to the 4t. And maybe we can take a pause. Okay, and we can do something similar for y prime. Y prime, in both terms, there is a exponential. 4 times AT plus 4 times B plus A Okay, and then we just replaced these values in our original equation, which is y prime minus 4 times y. Y double prime, going to write over here, minus 4 times y prime, or else minus 12 times y. And that has to be equal to t times e to the 4t. Okay, now let's replace our values for the derivatives of y and for y. So since we have the exponential term on the expression for our y, this is y. This is our guess, right? And we have the exponential on on 3 of them. We can factor out the exponential. So we have y prime, which is 16at plus 5at 16at plus 5 times r plus 16b. And then we have 4 times y prime. This will be something like this. Negative, once again, 16b plus a minus 4 times a. Is that correct? Just replacing the y prime. Yeah. I'm doing this operation. I'm replacing y prime and I'm multiplying it by -4. So I multiply -4 by every one of these 3 terms. And finally, we have -12 times y. And y is, as you can remember, at plus b times the exponential, but the exponential has been factored out. So we have at minus 12b. Is that correct? And it has to be equal to t times e to the 4t. So we have e to the 4t on both sides, and then we just compare the coefficients for the polynomial, for the first order polynomial. So we should have a first order polynomial on the left side. And we need to simplify our expression. So all of the terms having a t, and this cancel. And then we have just one term having a t. So this has to be equal to, to 1. So we have a value for A. Is that correct? And then the rest of the terms we have are 5 times A (16b). With this negative 16b is cancelled, so there is no. And we have negative 4 times A over here, and finally negative 12B. And that should be equal to 0 because there is no independent coefficient on the right side. So this is just 8 minus 12B is equal to 0, but we already know the value for A, which is negative 1 over 12. And from here we can find the value for B. And we have negative 12 will be equal to 1 over 12. So B will be equal to negative 1 over 12 times 12, and that will be equal to what? Is that correct? I think I'm missing.
Negative 1 over 144, no?
I think I'm missing something. I'm not sure about the result. This coefficient should be 4. Should have been 4.
Profesor, es que creo que está mal desde la segunda derivada.
Well, and now you're telling me that. Okay.
Perdón, me acabo de dar cuenta.
Okay. So let's check the second derivative. Okay. And what is the mistake?
Teacher, es que donde pusiste como el corchetito abajo de en el segundo renglón, tienes AE a la 4t y según yo ahí es 4AE a la 4t. Entonces cuando vas sumando da 8. O sea, da 8AE a la 4t.
Okay, over here?
Sí. Sí, ¿no? Porque derivarías el término de arriba.
Ajá, debería ser
sí.
4.
Y ya creo que con
Okay.
eso se arregla el problema.
We should have a 4 over here. I got it now.
Sí, porque ahí ya tienes, haz de cuenta, cuando eliminaste los exponenciales, ya más abajo, te queda más 8A menos 4A y de ahí sale el 4A que necesitas, que acabas de decir que necesitamos.
So this number 5 is wrong.
Ajá.
We need to have
An 8A
8
y con
times
el
8.
8 el 4 de más adelante cambia a 4.
Okay, thank you.
Yep.
Yeah. So I'll write value for B will be from this expression 4 times. So we have 4 times 8, we have a 4 over here. Right? And then a negative 12 equals to 4 over 12, right? And then we have 4 over 144. Can we simplify that? We can divide both terms, and then we have 1 over 36.
Yes.
Okay, that's the value for B. And we have just two coefficients. And now we're done. Remember that our guess was e to the 4t times a times t plus b. So our particular solution can be written as is a particular solution e to the 4 times t times negative 112, it is the value for a, plus b. And we can factor out the negative sign just in order to have a more elegant solution. And we are done. This is the solution, the particular solution for our given ODE, where the forcing function is a product of an exponential times a polynomial. In this case, it was a first order polynomial, but it could be a second, third order polynomial. And you need to solve more equations in order to find the undetermined coefficients of the polynomial. So this can be used whenever you have an exponential times any order of the basic functions. For example, let's work with another exercise. We have 3 ODEs over here, and we just need to write down the form of the solution, just the form. We're not going to find any solution. We just need to find the form because we are not given any ODE. We're just given the right side of an ODE, the forcing function, g of t. So if v of t is of this kind, we need to write down what the form of the solution will be. So for the first case, g of t is the product of an exponential times sine. So what is the form of the solution? We say, we just simply write down the exponential without any coefficient, and that will be multiplied by the solution of the sine. And what is the guess for the solution of the sine? Sine of 10t is a times sine of 10t plus b cosine. You see that? And that will be the guess. So if you're given an ODE with this forcing function, this will be your guess. Then you need to find the first derivative, the second derivative, you replace it on the original ODE, and then you will be able to find the coefficients A and B in this case.
Teacher, and what about the 16 we have over there? We just ignore it?
You just ignore it.
Because it will be absorbed eventually?
Exactly. That's why. you simply write down the exponential without any coefficient. Here are the coefficients, right? So in the second case, you tell me, please, what is the guess for your solution? And okay, in this case, we don't have any exponential, but we have the product of the basic function, which is a polynomial, times another basic function, which is a cosine. So what do you think your guess will be?
Teacher, wouldn't it be at squared plus bt plus c times a cosine of t plus b cosine of t?
Okay, let me write it over here. So a times t squared plus b times t plus c times the solution, the guess solution b,
Plus b.
b sine of t, right? Plus c sine of t, cosine.
Teacher, shouldn't we use different constant? Like
Yeah, you're absolutely right. This is another coefficient, and then we need to use d. And e over here. Okay. And then, okay, we have 5 coefficients, right?
Yes.
Okay, then maybe we can do the product. But still, we're going to have several coefficients. Let me think about it for a moment. Yeah, we need to multiply them, because otherwise we will have very complex work to do to find the first and the second derivative of this expression. So it is better. We're going to have more coefficients, but it is better to do this product. So we're having, from here, if we do the product, we will have a times d t squared sine of t plus b d t sine of t plus cd sine of t plus a e t squared cosine of t plus b e t cosine of t plus c e cosine of t. And of course, these coefficients can be written just as another constant. So we can call this constant just a, b, c, d, e, and f. And this can be written as a t squared sine of t plus b t sine of t plus c sine of t plus d t squared cosine of t plus e t cosine of t plus f cosine of t. And as you can see, there's a common term over here, which is sine, and in their case, it is a cosine, so we can factorize them, and we're left with this polynomial times sine of t plus another second order polynomial times cosine of t. So this is a very better expression that we can remember for the guess solution. As you can see, this is just the solution for the polynomial with different coefficients, times sine and times cosine. So whenever you have a product of a polynomial times a cosine times a sine or times a sum or addition of sine and cosine, your guess solution will be the guess solution for the polynomial times the sine plus the guess solution for the polynomial with different coefficients times the cosine. And that will be your best guess for those cases, for the product of a polynomial and a sine, cosine, or addition of both of them. And now, what is the guess for the third case? Let me take it down. Now let's write down the guess for our third case for the C. We have a product of an exponential times a polynomial times a cosine. So we can consider the product of an exponential times something. So our guess will begin with the exponential times something, right? Without the coefficient, of course. And that something happens to be the product of two basic functions, a polynomial and a cosine, a first order polynomial. So we apply what we have developed in the previous step, in the previous example, and that will be a first order polynomial, because this polynomial is first order, times sine, plus another first order polynomial. See, maybe here is better to write. Plus another polynomial times the cosine. It's 9t, right? That's the argument for the sine and cosine. And that's it. This will be our guess for this forcing function. Okay, questions? No one?
Nada más van a ser esos tres casos, profe, los que vamos a estar viendo.
Yeah, with the undetermined coefficients method, you can work only for ODEs having the forcing function with one of the three basic functions or a combination of them. A combination being a product or an addition. We have seen the product. And for the addition, the guess will be just the addition of the guesses for every term in the addition. For example, and that's the limit of this method. Because what if you have a tangent of phi t on the forcing function, can you use undetermined method, undetermined coefficients method? The answer is no, you cannot. Because you need to have one of these three basic functions or a linear combination of them. Linear being the product or the addition. So that's the restriction of this for this method. So what if you have another kind of forcing function, like another trigonometric function or like any other expression? Well, you need to use another method. And one of those methods is the variation of parameters method. So next lecture, we're going to work with the variation of parameters method. And that method will work for any forcing function. So that appears to be the method. However, it could be not simple to use because the method is based on finding the solution for an integral. And not always is easy to find the solution for a given integral. And that's the complex for the method. You need to be very skilled to find the solution for integrals. So if you have a forcing function like this one, you better use undetermined coefficient method. So you need to have a tool, a set of tools to find the solutions for ODEs. So if you detect an expression being a combination of these three basic kind of functions, you better use undetermined method coefficients. Otherwise, you will be using the variation of parameters method. Okay? So let me show you one last example for an addition. So what if we have something like this? We have addition of three terms. Well, we need to make a guess for every of these terms, and we just simply add the guesses. So we find a guess for this term, for the second term, and for the third term. And the third term in this case is just a product. So for the first term, we know our guess will be something like this. For the second term, we'll have something like this. And for the third term, we know we have something like the exponential times ABCD. So we know that our guess for the particular solution will be simply this one. And there you have. Ta-da! So you're ready to find a solution for all the E's having these three basic kind of functions or a linear combination of those functions. Once again, linear means product or addition of products of these three kind of functions. So once again, what if the forcing function does not have something like these three basic types or kinds of functions? Well, you need to use another method, and that method will be the variation of parameters. So next lecture, we'll be working with the variation of parameters in order to find particular solution for cases different to these ones. So see you, there will be homework for this weekend, of course, in order for you to practice the undetermined coefficient method to find particular solutions. Okay?
Teacher, for Sunday midnight?
Yes?
Okay.
So have a good day, nice weekend. Take care of yourselves, please. And see you
Thanks,
next
you too,
Monday.
Professor.
Thank you,
Teacher, see you.
Professor.
See you.
Goodbye.
Goodbye.